students, today in this class we will be calculating the analyzing of substitute frame method values for the moments calculation. In the previous classes you have seen how we have calculated and analyzed the moments by using the formulas and techniques of portal method, cantilever method, right. So, in the previous classes you have seen the portal method, there how we have analyzed for the horizontal loads. You already know that portal method, cantilever method, these are a part of horizontal analysis. Now, we will be solving for vertical. For vertical analysis, you have only one method, that is substitute frame method. Okay. So, for the substitute frame method, let us take any problem, how you should analyze, that I am going to show you procedure, right. You all remember the portal method and factor method and cantilever method, right. Yes. Yes, in the previous classes you know how to analyze that portal method, cantilever method and factor method. These are the three different methods for what? For horizontal analysis. Now, we are doing the vertical analysis. In that you have one method, that is substitute frame method. Okay. Let us consider a frame. Okay. So, this is how a frame looks like, right. Let us take one storage frame. Okay. It is fixed at the bottom. And let us take the distance of each beam is 6 meters. And let us take the column length as 4 meters. Okay. So, let us take this as the question. Okay. I am giving live load and dead load of 12 kilonewton and 20 kilonewton. Okay. And let us analyze for particular beam. Okay. For the substitute frame method, what you will do is, for a structure in the frame, you will take only one beam. Okay. For that you will analyze. So, first whenever you take an analysis procedure, what is your first step? Yes, tell me. Your first step is what? Is to name the frame, right. So, let us name the frame. B, this is C and this is D point. E, F, G, H, I, J, K, L. So, this frame is subjected to live load of 12 kilonewton meter and dead load of 20 kilonewton. Okay. Let us take these two loads. Okay. So, they act, see for example, now we will analyze for particular beam called BC. Okay. So, how you will take the loads? So, loading will be there for what is dead load actually? It will be there throughout the frame. So, from A to D you will have the dead load. When you are analyzing this for the BC frame, you will take live load on that particular area only. Then you will have the live load of 20 kilonewton here. Okay. And this is the dead load throughout the frame, it is 12 kilonewton. Okay. So, then what will be the next step, right? This is the question. Okay. And this is, you can see here, analyze the frame by using substitute frame method, which is subjected to live load and dead load. Live load of 12 kilonewton and dead load of 20 kilonewton. Okay. And the distance of each beam is 6 meters and the distance of each column is 4 meters. Okay. Distance in the sense, you have the length of that column as 4 meters and you have the length of that beam as 6 meters. Okay, students. Remember, so next, what is this first step? So, the first step for the analysis is to make the substitute frame. Yes, what is a substitute frame? The main frame which is subjected to loading and which you will analyze for the complete procedure, right. Now, your first main frame will be ABCD frame. So, let us assume these as fixed ends. And next, add loading to it. So, this is a main substitute frame, okay. In the next step, you will be taking the loading and moments, okay. So, that will be your second step. So, in the second step, you will be calculating the loading and moments, okay. Moments in the sense, first you will be calculating the fixed end moments only, okay, not the overall moments. The second step, you will be taking the loads of each member and the fixed end moments, okay. So, what is the loading part you can see for the beam? Let us draw this substitute frame once again and give the loading. So, what are the loads we have, students, here? Yes, what are the loads we have? Dead load and live load. So, the students, those who said this dead loads and live loads, they are right that it is subjected to dead load and live load. Okay. So, what is the dead load value? 12 kilonewton meter and live load as 20 kilonewton meter. So, let us calculate the fixed end moments. So, moments along, so what are the naming of this frame? A, B, C, D, right. So, moments along AB. As this is fixed end moments, let us write F, M, F, AB. Okay. So, fixed end moments, so what type of load it is? How will you calculate the moments? Based on what type of load you have, right. So, what type of load you have here? You have uniformly distributed load. So, uniformly distributed load, what is the formula for that? For the calculation of moment, it is WL square by 12. So, WL square by 12. So, it is clockwise direction, you will take minus, which is equals to minus what is the load acting on it? 12 into what is the length of this beam? It is 6 meters. So, 6 square divided by 12. So, 12 gets cancelled, 6 square is 36. So, it is minus 36 kilonewton meter. Okay. So, this will be the value for the fixed end moments along AB. Next, fixed end moments along BA. See, you will take both sides. Okay. So, moments along BA will be equal to plus WL square by 12. It is plus 12 into 6 square by 12, which is equals to 36 kilonewton meter. Okay. So, this will be the second moment. Next, along BC. So, along BC is subjected to two types of loads, that is live load and dead load also. So, live load you have 12 kilonewtons and dead load you have 20 kilonewtons. So, overall what is the load acting on the BC member? Yes. So, 12 plus 20, 32. So, you will take it as minus 32 into what is L? It is 6 square by 12. Okay. So, then you will get the value of this. I want you all to calculate with me, take your calcs and calculate and tell the value of moments along BC. Next, same way you will get the fixed end moments along CB. So, CB is 32 into 6 square divided by 12, okay, and you will get the fixed ends moment along BC and CB. Next, you need to calculate the fixed end moment along CD, which is equals to, so what is the load acting on it? 12 kilonewtons. So 12 into 6 square divided by 12, you will get, so this will be minus, so minus 36 kilonewton meter, right. Next, you will do for movements along DC. So what is the DC? This is plus 12 into 6 square divided by 12, which is equals to plus 36 kilonewton meter. Okay, did you all calculate it? What will be the value here? It is minus 90 kilonewton meter, and here you will get plus 90 kilonewton meter. Okay, so do you all remember what is moment distribution method? Yes, you all know what is moment distribution method already. So in the next step, what you will be doing is, you will take the moment distribution method of analysis, that tabular column, for 2 iterations. 2 iterations in the sense, for the 2 cycles of that value, right. First, when you see the procedure of the substitute frame method, it is very easy. It is one of the approximate method of analysis. So here, so when you analyze a frame, you will be doing is, first you will be taking the complete members. Next you have to see what are the loads acting on that. Then after that, first thing is, you need to note it down, the values of that members, right. You need to write that naming of that member. After that, you will just see the length of that each and every member of the beams and the columns. Next, first step, after doing all that work from the question, in the solution, what you will be doing is, first you will write the substitute frame. So what does the name indicates? What do you mean by substitute? Instead of overall analysis, you will just substitute one member, right. You will just take one beam and one floor of that, and you will analyze. So that is the meaning of substitute frame method. So you will take that substitute frame and just name it, and the second step, you will take the loading, and then you will see the moments of that. What are the different types of moments? Fixed end moments. So fixed end moment, for example, what is the load which is acting on this? Say for example, you can see here, it is subjected to uniformly distributed load, right, the dead load and the live load. So in the same way, it may have subjected to point load, it may have subjected to uniformly varying load. So different types of loads, you will have the fixed end moment. So after calculating the fixed end moments, what you will do, you will just calculate the third step, that is moment distribution method step, where you will be taking up to 2 cycles. Okay students, am I clear with the step 1 and step 2? In the next class, you will be seeing the step 3, you will see the tabular column, and you will analyze the frame by using the moment distribution method. So remember to see moment distribution method once again for the calculation of substitute frame method. Okay students, thank you.